Intermediate Algebra Section 3.5, Solving Applications with Systems of Three Equations. Systems of three or more equations arise in the natural and social sciences, businesses, and engineering. And we're going to take a look at an application here that has to deal with land or geometry. And here it is. A real estate investor is examining a triangular plot of land. She measures each angle of the field. The sum of the first and second angles is 80 more than the measure of the third angle. If the measure of the third angle is subtracted from the measure of the second angle, the result is 3 times the measure of the first angle. Find the measure of each angle, and they have a note here telling us that the sum of the measures of the angles in a triangle is 180. Well, drawing a picture isn't the worst thing in the world to help us solve a word problem. So we have a triangular piece of land. They're talking about the 3 angles. Let's assign those angles X, Y, and Z, and then see if we can come up with 3 equations to help us solve for these three unknowns. And here, this note is where we can start with the sum of the measures of the angle in any triangle is 180. So there's our first equation. The first angle plus the second angle plus the third angle is equal to 180. Furthermore, to come up with the other 2 equations, we'll read this portion of the problem telling us the sum of the first and the second angles, so that would be x plus y, is 80 more than the measure of the third angle. So we'll take our third angle and add 80 to it. The next sentence tells us if the measure of the third angle is subtracted from the measure of the second angle, that means we would take the third angle z and subtract it from the second angle. It tells us the result is 3 times the measure of the first angle. So let's get these in order so that they're all lined up variable-wise. The first equation looks great. We're going to leave it as x plus y plus z is equal to 180. We need to bring the z to the left. It's positive on the right. Subtracting a z from both sides will turn it into a negative. So we have an x plus y minus z is equal to 80. And the third equation, we need to bring our x term to the left. Subtracting a 3x from each side leaves us with a negative 3x plus y minus z is equal to 0. When we bring the 3x to the other side, there's nothing left there. So here's our 3 equations, and using the elimination method and to have it in a funnel or a triangular form, we need to get rid of these x terms. So a possible game plan would be multiply the first equation by a -1, then add it to the second equation. We'll eliminate the x in that second equation. So let me draw a line so we can see what's happening. Multiplying the first equation, as I said, by a -1 will change every one of those signs. They're currently all positive, so multiplying by a -1 makes them all negative. I'm not going to do anything other than add the second equation, which is x plus y minus z is equal to 80. And the result we're going to call our new number 2. We got a twofer in this one because not only did we eliminate the x term, but we also eliminated the y. We have a negative 1z plus another -1 is negative 2z. And adding negative 180 plus 80 leaves us with a negative 100. Dividing both sides by -2 gives us one of our angle measurements is equal to 50. So if we're recording our equations, the first equation we're leaving as is, x plus y plus z is equal to 180. Our new second equation is simply z is equal to 50. But we're not quite ready to solve this. We need to go back and get another one of our equations down to a single variable. So I'm still working on this funnel form. I want to attack this x term here, and to get rid of a minus 3x, my proposal is to multiply the first equation by 3 so that when it's added to the third equations, those cancel out. So here's the game plan in action. Multiplying the first equation by 3 will give us a 3x plus 3y plus 3z, and 3 times 180 is 540. I'm going to add it to 3, the third equation, without doing any modification. The x's are gone as hoped. We have a 4y plus 2z is equal to 540. We now have one equation with two variables, and we know one of those values. Z is equal to 50. So if we know what z is, we now can solve for y. So replacing z with the 50, we'll go forward then to solve. That leaves us with a 4y plus 100 when we do the multiplication. Peeling away the layers to get to the variable, we'll subtract a 100 from both sides. That leaves a 4y is equal to 440. And dividing by 4, maintain equality, multiply or divide both sides by 4. We end up with y is equal to 110 degrees. So now we have two of our three angles, and we can plug that into any one of those original equations that has an x, a y, and a z in it. And probably that first equation is the easiest one to use. So we don't know x, we just solve for y, it's 110. Z we found was 50, adds up to equal 180. Simplifying on the left, we get a 160 by combining like terms, and subtracting 160 from each side leaves us with that x, the first angle, is equal to 20 degrees. So to answer the problem, we would say that the first angle has a measure of 20 degrees. The second angle, which we assigned y, has a measure of 110 degrees, and the third angle we let z stand for had a measure of 50 degrees. And of course you'd want to plug these values into the equations to verify that they are correct.